we're going to look at some distance and travel problems. So that formula distance equals rate times time that you've probably seen in science class or math class before is what we're going to be using. So first off, we have Mary and Joe going to an FBLA conference. We have some info about the amount of time it takes and their speeds. It kind of helps if I arrange my information in a table. I'm going to fill in what I know. So first off, I know Mary travels 3 miles an hour faster than Joe. So if I label his speed as x, hers is going to be x plus 3. I know some times. The trip takes 3 hours from Joe's house and 2.5 hours from Mary's house. Notice that our rates and our times match in terms of units. We have miles per hour and time measured in hours. If they don't match, you're going to need to convert. Now, if I know that rate times time equals distance, I could multiply those rates and times I filled in to get my distances for Mary and Joe. And then I need to think about how I could use the relationship between those distances to make an equation I could solve for x. So another fact I know is Mary's distance is 30 miles less than Joe's because she is 30 miles closer. So if I set up an equation and fill in my expressions that I got for Mary's and Joe's distances, these two things should be equal and I should be able to solve for x. So I'll distribute my 2.5 in, and then I'm gonna add 30 to both sides, subtract my 2.5x, and then divide by 1/2 or just multiply by 2, and I'll get x is 75. So what we just found, if you go back up in your table, x stood for Joe's rate. So his speed was 75 miles an hour. Apparently we're cruising along an interstate here, or some bus driver speeding. I'm supposed to find both their rates. So if you look at Mary's rate in the table, it is x plus 3, or Joe's rate plus 3 miles an hour. So she must have been traveling even faster at 78 miles per hour. All right, I went ahead and set up my table. Basically, we're looking at a there and back trip, traveling against the wind when we went and with the wind when we returned. We know our times for our there and back, so let's fill them in. Now, if you think about what the wind is doing, if you're traveling against the wind, it's going to slow the plane down, so subtract from its speed. If you're traveling with the wind, it's going to speed the plane up, so it's going to add to your net airspeed. Since rate times time equals distance, I'm going to go ahead and multiply these to get my expressions for my distance. What we're looking at is a travel trip where we're going somewhere and coming back. We're going to assume by the same path, so that means that our distances should be equal. So if I set my distances equal, I went ahead and distributed here, took 3 times 180 minus x and 2.8 times 180 plus x. Those two distances are equal, so I should be able to solve my equation for x. So I will add 3x and subtract 504, divide by 5.8, and you get x is approximately 6.207 miles per hour. We were looking for the speed of the wind. That's what x stood for, so we are good to go. Here we've got 2 planes leaving Los Angeles at the same time. One's going to San Diego and one's going to San Francisco. I know the San Diego plane is flying 50 miles an hour slower than my San Francisco plane. I know I wrote 5 in my table. It takes me a while, but I do recognize it and fix it, so just go with it. Pretend the 5 is a 50. One thing that's important here is those rates are in miles per hour, but the time that they give us, say they give us that we're looking at it in 30 minutes, that's not the same units, so I'm going to have to convert 30 minutes to hours because my rate's in miles per hour. So 30 divided by 60 gives me 1/2 of an hour. Make sure that your units match when you're doing these. Then I can multiply to get my distances for my plane traveling south and north. Now those distances aren't necessarily the same. We're looking at after 30 minutes, and what we're told is after 30 minutes, the planes are 275 miles apart from one another. So I start in LA, I went one plane north, one plane south. So if you think about the total distance they are apart is 275 miles, and that includes both the distance that my San Francisco plane has flown north and my LA plane has flown south. So what I know is those total distances for my two planes individually should add up to 275 miles. Okay, here's where I realized that I made a mistake. Fixing all my 5s, turning them into 50s. Sorry about that. So the two individual distances should add up to your total of 275 miles that they've traveled in this half an hour. And then a little bit of just combining like terms here, solving my equation. You end up with x equals 300, which stood for your, if you look in your table, speed of your plane that was traveling north to San Francisco. And then I also need my speed of my San Diego plane, which is 50 miles an hour less than my San Francisco plane, so 250 for it.